Okay, I'm going to be doing the videos here for now, and a loose leaf and marker for now. This is the good camera as opposed to the other one. This is a little weird for me because I flipped it backwards so I can see myself, but this looks backwards to me, whereas it would look regular to you, and this looks good to me, whereas to you guys it looks like I wrote on a mirror. Okay, so I'm gonna have to deal with that. This lesson is for pre-calculus, how to find the range of a function. Basically, the domain, right? I'll give you a function. F of x is equal to the square root of x minus 4, right? Now, the domain of it would be what numbers can I put for x where it would make it true. For example, can we have a negative under a radical? No, because then it's not a real number. That's an imaginary number, right? So then, based on that logic, we can't have a negative number under a radical sign. If we can't have a negative number, we can have any other number. Negative numbers are numbers less than 0. So since we can have any other number besides a number that's less than 0, what else could we have? Numbers that are equal to or greater than 0. Or greater than or equal to 0. So, this inside the radical has to be greater than or equal to 0. You have your simple inequality there. Add 4 to both sides. The way you would write that as a domain the domain 4 included to positive infinity. The reason why infinity doesn't need to be included because infinity is infinity, so it's gonna go on forever. So okay, the range, however, is a little bit more. It's not hard. It's just more abstract. If I gave you this to be 4, what's 4 minus 4? 0. And the square root of 0 is 0. If I gave this to be 8, minus 4 is 4. Square root of 4 is 2. Now, if I gave it to be a number less than 4, say 3, 3 minus 4 is negative 1, and we can't have a negative number. So, based on that logic, the only numbers we can get out as a result of a radical sign are either 0 when whatever's inside the radical is 0, or any number greater than 0. Does that make sense? Like, we can't have... The range is basically what f of x is going to equal. Okay? So, if we have a 4 for x, then f of x is going to be equal to 0. If we have 8 as x, then f of x is going to be equal to 2. Right? However, and now think about it this way. If I put 4 again, right? 4 minus 4, 0. If I put 8 minus 4, 4. Square root of 4 is 2. However, also negative 2. Does that make sense? Negative 2 times negative 2, right? 4. So, basically, it can equal any number. Does that make sense? It's whatever it can equal. So, a radical can equal any number. Just whatever's inside the radical can equal any number, because you can't have a negative. However, the result of the radical can be negative. For example, okay, f of 4, you plug in 4, right, for the original x, minus 4, square root of 0, 0. Plug in for 8, plug in 8 for x, minus 4, square root of 4, positive or negative 2, right? And you can put any number, and that'll give you, the range from any number to any number. Negative infinity to positive infinity. You would write that. Simply as that. And that's the range. It's not that easy for more complex functions. For example, f of x is 1 over x. Right? The domain is what can x equal so that I get a real number. And remember, real numbers can also have decimals, right? Well, actually integers. Sorry. Not real numbers, integers, because an integer also includes negative numbers. However, let's say you have a 0 here. If you have a 0 as a denominator, that's undefined. It's not 0, it's undefined. Undefined is, well, undefined, right? So the domain is, the denominator cannot equal to 0. Since the denominator is x, x cannot equal to 0. So you would skip 0. Domain is negative infinity, 0, or 0, positive infinity. This is a marker, so pretend this is positive. Okay? The range. Now, this fraction, right? If I were to plug in 2, what's 1 over 2? Half. If I were to plug in negative 2, that's negative half. If I were to plug in 1, then it's 1. If I were to plug in negative 1, then it's negative 1. If I were to plug in 0.5, then it'd be 2. If I were to plug in negative 0.5, it'd be negative 2. However, no matter what I plug in for this x, this fraction will never give me 0. Why? Because in order for it to be 0, the denominator doesn't have to be 0. The numerator has to be 0. And here they tell you the numerator is 1. Since the numerator is 1, it's not 0. This fraction is never going to equal 0. So, and there you go.